Okay, this tool right here is called a knurling tool. And you can see it's got two cutting heads on it. And actually what these do is they don't really actually cut material, is they actually displace it. It's almost like rolling threads. So we're actually going to create little points. It should almost look like little diamonds that we're creating when you form a full knurl. Okay, and you have to push hard enough in order to do that. And once you get, it's like a thread. Once you get it timed in the these little wheels get timed in grooves, you can't try to restart the knurl. You got to do it all in one shot. Okay, so the first thing we want to do is straighten our compound rest back up. So the compound rest has to move back to the middle position, right in the center. Okay, lock it down again. Okay, then what we're going to do is we're going to put our knurling tool in one of these tool holding positions. Okay, and we want we want it to be on the left side of the tool holder. So we're just going to clamp it in place. Clamp it tightly so that it can be held securely. And it has to be straight ahead. You want to have it on one way or the other, otherwise your knurl will be uneven on one side. Make sure it's nice and tight, not gorilla tight, but snug. Okay. We're going to knurl at a much slower speed than we actually machine this. I don't think it says it on your sheet here, but we want to go probably around 395 RPM, which would be in the low speed and in the top position. Okay, so 395 RPM would probably be good. Let's get an idea how fast that is. Okay, fairly slow. The second thing I want to do at this point, after you get the power and everything turned off, is tighten my chuck up again. Okay, and tighten up the tailstock. Okay, because if that tailstock moves, you're going to be in trouble. Make sure that's all tight. Okay, that's good. And then I'm going to turn power back on. And what we're going to do is we're going to find the start of our knurl. We're going to come in, push fairly hard, and then move the knurl back and forth. I'm going to do it manually. You can do it with feed, but it's you can actually do it manually. It'll be fine as long as you try to move it uniformly. Okay, so you come in, push pretty hard. You got to hold your hand on there, and then I'm going to move it along, keeping the same tension on the cross feed. I'm going to go right up to that line, and I'm going to go back the other way. Try to do it uniformly. Hopefully we'll have a good knurl. Sometimes it doesn't always work out. Okay. The first time back and forth wasn't quite hard enough. You can see I do have a full knurl down on this end, so I'm going to try to retime it again, and sometimes we can bring this area back in. The full knurl should look like this diamond's on this end. Okay. Go in slowly. Yeah, there we go. Full knurl's forming. Takes a lot of force in order to get the knurl to form. So there'll be diamonds on the handle all the way along. You actually see grooves forming right now. Good. Completely formed knurl. We have little diamonds that come to a very sharp point at the top of each of them, and it ends where it needs to. Don't go all the way to the edges of those chamfers on your knurl. Just go to the ends of the lines you created. Okay, the next step we have to do is to go over to the milling machine and put the grooves in here, and then after that we'll cut our screwdriver off. Okay? Okay, this particular tool here is an indexing head. And the way this tool works is it's got a 40-to-1 gear ratio inside of here. And when we turn this handle here, you can see that the chuck rotates. Okay? And so if we have a 40-to-1 gear ratio, if we turn this around 8 times exactly, we'll get 5 flutes on the diameter. This is the way that the ratio works. There's actually a whole chart that you can look at to make, 15, 12, whatever the number of divisions of holes or whatever you want to do around a part. You can figure that out. And these plates here with the number of holes on there, it's kind of neat. You can actually, if something doesn't go into it evenly and there's a remainder, you can actually figure out with this little V plate here, you can actually take and do a remainder. So in other words, if it was 5 and 2/3 or something like that, you could go 5 revolutions and then 2/3 of a revolution by putting it in the right holes here. Okay, but we're going to do it easily, and we're going to go 8 revolutions, and that will give us 5 flutes. Now, whoever's doing this, don't talk to them. Don't screw them up. Otherwise, their flutes are going to come out in the wrong spots. And what I mean by a flute is like these little grooves, these little channels that we're putting into our screwdriver. Okay. There's a little mark on the top of this of the dial here, and you can start and stop at that mark. So what I would do is pull it out, hold it out all the way out, the spring load here. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then you can machine your groove. So make sure it's chucked up in there tight. Then I loosen the tailstock here. We're going to bring that in. Okay? And we'll tighten this down. There's should be an adjustable wrench around. There it is right here. Okay, snug that up. Okay, the other thing is, this thing tightens in the reverse direction. You unscrew on it to tighten the center. Okay, so now we're centered, we're chucked up in here tight, and we're at 0, so we're going to machine our first flute. Okay, the way a milling machine works, we have a spindle head, and we have a table. The table moves in the X direction, which is crosswise. It moves in the Y direction, which is in and out, and it moves in the Z direction, which is up and down. Okay, up and down, this is this big handle here. You see it's going down right now and coming up. Okay, this area here is called the knee. The knee lifts the table up and down. Then the spindle, we have to get the right speed on the spindle, and if that's correct, it's going to cut material, and it's usually an end mill that we're using. An end mill cuts on the periphery, and it's kind of like a drill bit that you cut sideways with. Okay, and it's a lot shorter than a drill bit, so that it stays stiff. The particular tool we're going to use is a half round. It's going to create a semicircular cut in or make a flute in our part. We're going to be moving the x-axis, and the way we do that is we use the hand crank over here, okay? Or you could use the automatic feed, which is on the opposite side. And I'll show you how to use both. One thing I don't want to see you do is put tools on the table or on the ways. This surface here is a way, and this is where the table slides back and forth on it. It's a very accurate surface, so don't set anything on it. Okay? We want our groove in here, I believe, to be about 50 or 60 thousandths of an inch deep. So what I can do is, I can bring the table over, and it's got to be right in the center, and I have it centered right now in the Y direction. Okay, I'm going to bring the table up to it, just touch it. Now the way to do that is you put a piece of paper underneath here, and you can tell whether when you're about 3/1000ths of an inch away, that piece of paper will start to grab. Okay. Right now I'm just going to do it by eye. Okay. So now I'm going to go. If you look at the divisions on this vertical axis, the Z-axis, I can zero this collar. Then what I'll do is I'll bring the table up 40, 50, 60, 62 thousandths, a 16th of an inch. Then what I'll do is I'll flip the handle backwards so that you can't move it. Okay. What you can also do is you can lock. You push this little lever over here, it will lock the vertical axis. Don't ever try to turn really hard on one of these levers. If they don't turn easily, it means that the axis is locked. If you don't know how to unlock it, come to me and I'll tell you how. There's little levers on all these axes that lock them. Okay, so now it's locked in place. We have our spindle, the depth that we want to cut. It's off the part in the open area here. We're zeroed here. Okay. And then I'm going to come up here and turn on the spindle if everything's okay. The on is right up here. You can see that on the spindle here. So there it goes. Yep. Okay. Now we're going to feed in the X direction slowly. It also put some wax on our part if it's not cutting so good. Don't go too quickly. You'll build up aluminum on the tip, and it'll make if it starts making bad noises, like kind of grinding noises, stop and get me. Either the tool's dull or it's plugged up with aluminum. Okay? Is that a deep enough of a groove? It's kind of up to your preference. Let me take a look at it. You don't want it too deep though. I think I went a little bit deeper than that. Let's go like 90 thousandths. Okay, so I'm going to bring the table up to 90 thousandths. I'm going to unlock it. 80, 90 thousandths. Lock it again. Okay, I'm going to go back the other way. Yeah, that's more like it. Okay, when you're done, make sure you clean all these chips up. Sweep them up, put them in the aluminum can that's right there. Okay, now, I have my groove. I'm back in the neutral zone. I'm going to go around 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to put my next groove in there. Slow. If you want, you can go in one direction and then do your turning over here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. It really doesn't matter which way you go. Okay, if you want to slow the machine down, you make sure you don't go in and move anything until it stops. But this is a brake. If you push sideways on this brake at the top here, it will slow the spindle down. Don't push that on, of course, when the motor is actually on and running. So here we go. we should have all 5 of our flutes, and if we did it correctly, they should be even around the diameter. After you're done, you can either move the table back down, or you can actually take and unlock the quill and lift it up. This little locking lever on the side here, that locks the quill, and when you unlock it, you can move the quill up and down. So you have 2 ways in which to move vertically. You can either move the quill, lock the quill, and then you can do it accurately down here. You don't really know where you are when you use the quill, though. Okay, now we're going to unlock, or take our part out of the chuck here and see how it is. Okay, at this point we have our flutes in the screwdriver. We have it knurled. Only thing we have to do now is thread the end and cut it off. Okay, and we can start the thread in the lathe. That's an easy way to get it straight. And then we'll continue the thread out of the lathe, and then we'll come back in here and part off our screwdriver. Okay, we got our screwdriver back in the chuck and it's tightened. I got the lathe turned completely off. We don't want to even turn the lathe on now. The only thing we're doing at this point is we're going to use this tap handle and get it straight by using our center to get the tap straight. This is kind of a trick you can do. A lot of the tap handles you get will not have this hole in the back side of them. So the first thing I do when I buy a tap handle is I drill a hole back here so that I can tap a straight hole. You can do this in a drill press as well. If you just drill the hole, you can put a taper, a 60-degree angle bit, you know, you sharpen a piece of steel with a 60-degree taper on it, and you put that in your drill press, and you can use that to center it. Okay, what we're going to do is we're going to put a little bit of wax on. This is a 1/4-20 tap again, and we're going to come in here and we're going to tap. Now, what you want to do is leave your tailstock loose and gently bring this in here to get it started. You can put pressure on it, push forward on your center. You can see now it's starting to tap its way in. Now, don't just keep on screwing it in there. At this point, we've got it fairly straight in there, and we can take it over to the vise and do it. Don't turn on the lathe. If you ever seen anyone do that, it's just one of the stupidest things you can do from the standpoint of safety. Okay, and you can probably even just do this by hand now. You kind of a couple turns forward, turn backwards, and bring it back out every once in a while. Clear out the threads. See, there's a lot of aluminum stuck in there, so you can kind of take and run your fingernail down the flute. Can you see that? If you run your fingernail down the flute, you can kind of take those chips out of there. Okay. Make sure you get it the same way in there the second time as you did the first time. If you want, you can put this in the vise as well. But once you get it straight in the hole, then it's usually pretty easy to do. Okay? You want to tap it as deep as the threaded part on your screwdriver, or even more than that, because remember the end of the tap this is a taper tap, so the first 7 threads or 6 threads are not fully formed. Okay, that's as far as we can go. Take it back off. Clean that out. Okay. That looks pretty good. Now at this point what we have to do is we have to part the end off using the parting tool on the lathe. And then pretty much our screwdriver is done. All we have to do now is to put the screwdriver blade in there and use some Loctite. Okay. What we have here is called a cutoff tool. It cuts on both sides, so it's just going to basically go in or part the 2 pieces in half. One of the things that's very important on lathe work is that the height of the tool is exactly on center. Now you can see that the height here is not quite on center. We're about 1/8 of an inch low. So what we need to do is we need to get a spacer to put underneath here and to bring this up to the center line of the part. So always check that. If your tool isn't right on center, you might have to put a spacer underneath it to bring it up on center. Otherwise it'll cut poorly. Okay, we got our part raised up 1/8 of an inch. We want to make sure that parting tool is exactly straight. If it's not straight, we're going to be in trouble. And the other thing we don't want to do is we don't want to use our tailstock when we're using the parting tool, and we want to make sure that we don't cut it all the way off, because otherwise the screwdriver is going to come flying out at us. Okay, we're going to go on the lowest speed again, the 395 RPM, and we're going to need a fair amount of wax on the surface when we're doing that. So get a little bit on there. And basically the place that you want to do it, you want to make sure you cut it off to the right length, because that's one of the things that we measure on your screwdriver. We go right at the end of that chamfer, okay? Or what you could do is you could go and measure again and mark it off exactly where it needs to be, but I can see where it is right now, right at the end of that chamfer. Okay, I'm going to turn the lathe on, slow. Okay, don't cut it all the way off, leave about, a quarter of an inch in the center. Go very slowly. If it makes a lot of noise, come and get me. We might have to sharpen that tool. Or if it's not cutting straight or even. So yeah, the goal is not to have it fall off here. The rest of the way we're gonna machine, or we're gonna take the rest of that material off with a file. Okay, that's good enough. Okay, now at this point, all you gotta do is break it off. So now we have our screwdriver. It's parted off on the end. We have our thread in there. It's just a matter of filing that off a little bit and putting our screwdriver blade in there, and we'll be done, ready to turn in.